My presentation this morning, I want to thank you all for being here and being a part of the workshop with us. My presentation is going to focus on the April 13th, 2020 outbreak. This was a unique and high impact event, not only for our area, but also for the state of South Carolina and parts of Georgia. So the general outline for the presentation will be as follows. We'll briefly touch on what happened, give you a little bit of statistics from the event itself, and also provide a timeline of the tornadoes. Then we'll get into a little bit of synoptic mesoscale setup for this event. Also look at how our office tried to message this event to the public and to our partners. Then we'll touch a little bit on some of the radar analysis. I'll show some images of some of the features that we look for when we're working a severe weather event like this. And then lastly, I'll try and wrap it up and just kind of put the event into a little bit more of a historical context, not only the event itself, but also the environment, which was a fairly extreme environment that supported this event. So if you look here, this is a map of the summary across our area. You see in total we had 8 tornadoes across our area. 5 of those were EF3 rated, 2 EF2 and 1 EF1. The average path length for these tornadoes were about 15 miles, which is quite a long path length considering our normal tornadoes that we have in our area usually aren't near that long. The average path width was about 500 yards. Unfortunately, we did have 2 fatalities and 7 injuries associated with these tornadoes. And there was nearly $10 million in damages across the state, with over 1 million of that occurring in our forecast area alone. Here's a look at a timeline of the tornadoes. You can see it started just before 5 a.m. The first tornado touched down in northwest Burke County, and continued on to just a little bit before 7 a.m. Ending the last tornado down from Roseville up to Cameron, ended about 6:37 a.m. So you can see it's a really confined event to a very short period of time, which led to the challenge of the event itself. The storms were really moving quite fast. And you'll see here at 5:51 a.m. we actually had 4 tornadoes on the ground simultaneously at one time, which again really led to a very challenging event for us in a warning perspective. And then just 2 minutes later, 5th tornado touched down at 5:53 a.m. 2 of these tornadoes were long track and long lived, over 30 minutes long on the ground, as well as over 30 miles long in their length. So some of the factors that contributed to this tornado outbreak, we had very strong wind shear in place. There's abundant moisture available to help fuel these storms. There was strong instability, which again also kind of helped fuel the intensity of the storms. And we had an upper level trough approaching that was a forcing mechanism to provide that large scale lift to help maintain and organize these storms. Overall, it was a very well forecast event from a model perspective. There was strong signals showing up many days in advance. And to that end, we began even talking about this in our area forecast discussion on Monday, April 6th, which is a week ahead of time. So it's pretty rare that we'll kind of talk about that far out, but the signals were there. For those of you who aren't familiar with our AFD, the area forecast discussion, that's a product that we use where the forecaster can provide their thoughts about the forecast, provide any sort of confidence and uncertainty related to the forecast. So if you're not familiar with that, that's a really good product to look at and get more information. So the next few slides are a little more technical in nature, so and really kind of geared more towards the meteorologists on the call and the broadcast media. So just kind of bear with me as I go through some of these. This is looking at the 250 millibar analysis. This is basically the upper level jet stream, and you'll see how that strong upper jet was moving out of northern Mexico, East Texas area, across the Gulf Coast states and into our area late on the 12th and early morning of the 13th. And this is basically a river of strong winds in the upper atmosphere that moves systems across the country. And the significance of this is that it provided that strong lift which is needed to help support and enhance thunderstorm development. Go a little bit lower in the atmosphere, around 500 millibars. Another important feature that is really associated with some of these stronger outbreaks is a pronounced 500 millibar trough. And you can see that moving out of the Texas area into the lower Mississippi Valley. And then by the early morning of the 13th there, it was moving up into the southern Appalachians and moving into our area. And the significance of this is it provided additional forcing in that upper lift that we talk about, but it also really enhanced the wind fields and the wind shear during the early morning hours when that event was moving through our area. Go further, a little bit lower, look at 850 millibars, is just above the surface. Here you'll note a 60 to 70 knot low-level jet out of the south-southwest. This was bringing strong moisture transport into the area, as well as it contributes to the very fast storm motion of the squall line as it moves through the area. It also further enhanced the low-level shear, which was a supporting factor in the tornado formation. So now we'll take a look at some of the instability parameters and kind of break these down a little bit. The upper left panel here, and the timing of this is at 9Z, which would be at 5 a.m. Eastern Daylight Time on the morning of the 13th. So it was really right about the time the tornadoes were starting to touch down and move across our area. The upper left panel is the most unstable cape, and you'll see here those values pretty much over 2,000, centered over the central and eastern Midlands into the lower CSRA along the coastal parts of South Carolina and Georgia. And that's pretty significant values of CAPE in our area, not just in general, but especially at this time of morning. The early morning usually don't have a lot of instability available just because of the timing of day with the lack of surface heating. But that's provided strong, long-lived updrafts to keep these storms going. If you look at the lower left-hand panel, this is the lifted condensation level. And basically, what we're pointing out here is when you have very low values of lifted condensation level, in this case here, they're at or below 500 meters, which is around 1,500 feet. That's a really favorable parameter for tornadoes to reach the surface. And in the lower right-hand corner, this is the precipitable water. And that's basically a measure of the amount of atmosphere, amount of moisture in the atmosphere. In this case here, we had values up around 1.8 and 1.9 inches, which is extremely high any time of year, but especially kind of in the springtime. Now take a look at the wind shear parameters. Look at the upper left-hand corners, the bulk shear in the lower 6 kilometers of the atmosphere. We had bulk shear values over 70 knots, almost 80, 90 knots there coming into the CSRA at the time. And this is one of the parameters we look at that really helps to organize storms. Values over 30 to 40 knots are favorable for supercells and increased tornado potential. The lower left-hand panel here, this is the storm relative helicity. This is basically kind of that parameter that kind of indicates how much shear in the lower levels. It kind of helps spin up tornadoes. In this case here, we had values at or above 500 meters squared per second squared. And that's a fairly significant value, way higher than what sort of the normal threshold is. Values over 100 are correlated to increased threat of tornadoes. And I want to show this lower right-hand panel, the 3 kilometer change in the storm relative helicity there. And you'll see, again, this is right at 9Z, right about the time the tornadoes were starting to spin up and touch down in our area. And you'll see that the storm relative helicity values increased by about 100 meters squared per second squared during this time. And lastly, I want to touch on a couple of these composite parameters that are produced by the Storm Prediction Center. I want to get into the details of what these really are, kind of get to the weeds there, but the key I want to really point out here is those bullseyes that you see pretty much over the eastern Midlands in both of these parameters. Supercell composite parameter values over our area where the tornadoes occurred were over 35, and according to the Storm Prediction Center's research, their values over 8 is when you become pretty significant. So you can see we're just completely off the charts with that parameter there. And the significant tornado parameter is also an indicator of, through their study, a majority of significant tornadoes, which is a EF2 or stronger intensity tornadoes, are associated with values greater than 1. In our case here, we had values up over 7, close to 8 at the time the tornadoes came through. So again, these values are just on the extreme end of the spectrum. So now we'll take a look at kind of leading up to the event here. This is the Storm Prediction Center outlooks 4 days prior to the event. This is on that Friday beforehand on the 9th. And so 4 days out, the SPC had placed our area in a 15% outlook of severe weather. And this is maybe a little more equivalent to what you think of when you look at the day 1, 2, and 3 outlooks of a slight risk. So usually pretty unusual that we'll get something outlooked in our area that far in advance. Usually that's kind of reserved back for the Central Plains where you have more tornadoes in general, but it was an unusual event because due to the high confidence that something was going to happen. So they went ahead and outlooked us in that risk category. And so given this information, we went ahead and started issuing partner briefings that day on that Friday, trying to get the information out to our partners, to our emergency managers, and to the media, as well as starting to promote it on our social media. Really want to kind of get the word out, just because this had the potential to be a significant weather event for our area. And not only that, but it was the Easter weekend, so it was a holiday weekend. Maybe people wouldn't be as in tune to things during the weekend as they might otherwise be. And as well as going to be a nighttime event, which is somewhat rare for us, and we'll get to that later on when I get to some of the climatology. And you even saw that from what Frank presented just previously. Nighttime events for us are relatively rare for tornadoes. So then moving up to one day prior to the event, this is the Sunday, April 12th, and during the afternoon hours, Storm Prediction Center upgraded us to an enhanced risk over our area. And these are relatively rare for our area. We get maybe 1 or 2 of these per year on average. So that really kind of elevated the risk of this event for our area. And you'll see on the left-hand side, there's 2 images there. And the reason for that is because their outlooks run from 8 a.m. Eastern Daylight Time to 8 a.m. Eastern Daylight Time. So that's why they have 2 of them. The first one covers the western half of our area, and the second one covers the eastern half of our area. But one of the takeaways we kind of thought about after the event with this, and having the benefit of having hindsight of what actually happened, given how well forecast this event was and how extreme those parameters were, maybe we could have been or should have been a little more proactive and with SPC and tried to maybe ask for a higher risk category outlook, maybe into that moderate category. According to their definition up there, you kind of see it's widespread severe storms likely, long-lived, widespread, and intense storms, which is what we ended up having. Also at this point, a day before the event, we already have our office staffing in place. We plan on having extra people in to help out with the event. So we definitely don't want to get caught not having enough people in the office to kind of help out with a large event like this. Also, when they upgraded us to that enhanced risk, they put us in a 10% probability of tornadoes. You think about 10%, if you think about chances of rain, that's really not a lot, but you're talking about tornadoes, that's actually a pretty high value. And they also added the black hatching for us, and the significance of that is that represents the potential for significant tornadoes, those EF2 and stronger intensity tornadoes. So again, this just further increased our confidence that we're going to have a significant high impact event over our area during the early morning hours on the 13th. So given that additional information, where they bumped us up to enhanced risk, we decided that it's probably a good idea to go ahead and do a partner briefing that afternoon. So we did a webinar briefing there. And I pulled this slide out here to kind of really show where we really want to stress and provide enhanced wording that we were expecting isolated tornadoes for sure. It's not just possible anymore. We were expecting tornadoes will occur. And a couple of those tornadoes could be strong, EF2 or stronger. So we really wanted to really hammer that down and get that out to the media and to our partners and let people know this is going to be a significant event. You really need to be aware of it. Stay aware to the potential. Also, I want to show this the lower right image there, the severe weather threat and confidence graphic. A lot of times we'll have maybe some low confidence in an event that may be elevated or significant impacts, or sometimes we'll be high confident we're going to have an event, but we're expecting the impacts to be relatively limited. But this case here, we have pretty high confidence that we're going to have a pretty significant event there. So we really want to put that in there, and again, sort of keep that at the forefront of everybody's mind to make sure they're aware and prepared for this event. So we think in terms of our office staffing for this event here. This is kind of a typical setup, but also applied for this event here. I happen to be the lead forecaster on shift for that midnight shift that morning. We had myself and one of the forecasters. That's the normal shift when we have just routine weather going on. But we had 3 to 4 extra people in to help out with the event. We had one person designated as the event coordinator, and that person basically kind of oversees all the operations just kind of keeps track of all the warnings, lets us know when things are about to expire, that sort of thing. And they manage kind of all the internal communication within the office and make sure everybody's getting the information that they need to be able to work most effectively. The media coordinator is someone assigned to kind of be in the NWS chat, keep track of social media, really kind of keep those things updated and let people know what's going on as the event's unfolding, where damage is occurring, where the storms are moving. If you had any kind of interviews that were being requested from, say, the media or whatnot, they would kind of handle that. Obviously, in this case here, we just didn't have any, we would have time to handle that at the time anyway during the event, but that is what the role this person would handle. We also have multiple radar operators. It's always good to have multiple eyes looking at the radar, especially when you have a big, heavy, strong, high-impact event like we're expecting. We also have to have one person that continues to do the routine products. Our public forecast has to continue to be updated. The aviation forecasts, all that, the kind of routine products. Then we have another person that's dedicated to verification. So this person's making phone calls to the emergency managers, calling the 911 dispatch centers, trying to get information about any kind of storm reports that are out there. They also receive calls to the office that come in with that information, and they'll issue the local storm reports to get that out. And I'll stress here again, I think Leonard will probably get on this too a little bit in his talk. But really getting those real-time reports is extremely important, especially in an event like this where we had significant damage occurring with these tornadoes. If we can get that information in real time as much as possible, that's something we can put into our follow-up statements and get that information to the people that are living downstream of these storms or where they're heading and provide that additional information to them. So that's really kind of a key thing if we can get that information. As far as the warning strategies, since I guess I was on the lead forecaster on duty at the time, I decided to separate the warning, the way we're kind of handling the warning. So I had one person just doing all severe warnings because there was a squall line coming through with damaging winds with the event itself, but also want to have one person focusing on just the tornadoes. So there's no other distractions of looking at anything else or doing anything else, only looking for tornadoes and issuing tornado warnings. And then if we had another person available, that person would kind of help out with the follow-up statements and keep the two warning operators kind of free to just look at the radar and put out the warnings and not be having to deal with anything else. COVID did add to the challenge of this. It was right about the time when things were kind of getting spun up with restrictions and that sort of thing. So we had limited staff available. Fortunately, we did have one, maybe two, I can't remember now, at least one, maybe two people that were working at home telework, and they really kind of helped out with the verification process and making phone calls. So we kind of made it work for how we had to. So now we'll take a look at some of the radar imagery here. I'll let this loop through a couple of times here. What you'll note here is this is the loop for the whole event as it moves across our area. It initially starts out as generally a linear squall line convection moving across central Georgia into our area. But as you see, once it gets to about Waynesboro and the Augusta area, you'll see it kind of transitions to right about there. You see a big ball just north of Waynesboro moving up towards Orangeburg. It transitioned to embedded supercells within this line. And this is kind of a result of the confluence of that extreme moisture we had in place, the strong vertical lift, the strong instability that was there, and this enhanced wind shear. Think back to where I showed those two composite parameters, the supercell composite and the significant tornado parameter. It's kind of maximized right here over the Eastern Midlands, and right about that time when this line hit that area where those values were really, really high and extreme is about when that transition occurred. So here's a look at a typical 4-panel radar display that a lot of forecasters use when we're in this type of an event here. The upper left-hand panel is the radar reflectivity. That's probably the most familiar product that most people are used to looking at. The upper right panel is the storm relative velocity. And what that's showing there is the wind within the storms as it's related to the radar. So those blues and green colors and the light purples are strong, winds moving towards the radar, whereas the reds and orange and pinks are the stronger winds moving away from the radar. And the lower left-hand corner panel is the correlation coefficient, and this product here is used to determine sort of the uniformity of the droplet size within the storm itself. So anytime you have a really high correlation coefficient up near 100% there, those really dark magenta, purplish colors, That's basically indicating that all the droplets in the environment are the same size and width and height. When those values start dropping to lower values into the yellows and greens and even the blues there, that means that there's different sized particles that are being observed within the storm itself there. In this particular case, at this time, this is at 9:36, which would be 5:36 a.m. Associated with one of the tornadoes there. You can see we have a minima in the CC there, and that's a result of the damage that's being occurred from the tornado. All that debris is being lofted up and being seen by the radar. And those really dark blue colors that are associated with the correlation coefficient are indicative of non-meteorological phenomena. So that's another indicator that it's not just rain in there or different particles or maybe some hail or anything else in there. When you get those really dark blue colors in there, that's non-meteorological related particles. And in the lower right-hand corner, this is just a normalized rotation product that we use. It just really kind of helps pinpoint and easily detect where you have some strong rotation within the storm there. See, in this particular case, the values of NROT were 2.15, and anytime we get values around 1, approaching 1 or exceeding 1, that's when we sort of really know there's something maybe significant going on there, and kind of a threshold that we use for a potential tornado warning. So we go forward just a couple minutes later. This is a look at the radar reflectivity here. You can see on the timeline on the right-hand side there, I've kind of put a mark, a red bar of what time this is. And so this is occurring with these two tornadoes, the EF3 that went through Williston and Springfield, and the EF3 that went through the Eastern Savannah River site. And so what I want to point out here is these two enhanced reflectivity signatures here. And what that's indicating is the debris that's going on because of the tornado within the storm is really enhancing that reflectivity at that particular location. That was another kind of challenging thing with this event. Even though we did have supercells within this embedded line, it was really hard to see the classic supercell structures that you would really look for, like a hook echo and that sort of thing. They were there, but it was more subtle because it was embedded within the line, the squall line of storms itself. Now we'll look, this is, just 2 minutes later at 5:40 Eastern Daylight Time. Again, this is that correlation coefficient product I was talking about. And again, you can see the really large areas of the really low values of the correlation coefficient down in those blue category, again, blue colors. And again, it's indicating there's significant debris occurring with these tornadoes at this time. And so as you see on the right-hand side there, we already had a tornado warning out for this before this image came in, but given what we're seeing there and those damaged debris signatures, we upgraded the tornado warning from radar indicated to a radar confirmed tornado, and then put in that considerable damage threat tag down there at the bottom, just to really kind of indicate this is a really dangerous situation. You know, it's a large tornado on the ground that's producing significant damage. So we really kind of use that new impact-based warning information to kind of convey the threat a little bit better than we have in the past. This is a look at the correlation coefficient, just looking at a cross-section view here. I can't remember exactly what time this was, but what I wanted to point out here is that you had two distinct, debris signatures again. But on the left-hand side here, you'll see it's kind of confined up here around 10,000 feet, and it really isn't at the surface down there in the lower levels there. I think what's happening there is that tornado has actually dissipated or lifted, but you still have this debris being lofted in the air and continuing to move further within downstream in the wind of the storms itself. Whereas on the right-hand side, you have a significant tornado occurring with damage from the surface being lofted all the way up to about 20,000 feet in the air. And you kind of hear these stories with these significant outbreak events here where people find letters or photos from somebody else 30 or 40 miles away from the storm itself, from where the tornado actually occurred, and this is how it happens. Then I want to show this little loop here. This just kind of correlates or shows the correlation coefficient overlay with the tornado track itself. So, given the intensity of these tornadoes, the radar is really able to pick up these debris signatures very well. I made it pretty clear, but what I want to kind of point out and notice here, like I was talking about at the end of these, you can kind of see those debris signatures continue well on beyond the actual tornado tracks themselves. And again, that's, this debris is continued to being lofted up in the air, continues to move downstream. Those very strong, fast winds associated with the actual line itself. So now moving to just a couple of storm damage photos. This here, I believe, was over around the Savannah River site. You should see just the wide swath of damage to this forest of trees on the left-hand side there. It's just completely flattened and wiped out. On the right-hand image there, you can see again just a wide area of really strong damage. If you look at the trees there, you can look at the tree pattern the way it's laid out. You know, typically with tornadoes, this is what we'll see. We'll see it kind of falls over like matchsticks. It kind of shows that convergent pattern. They're all kind of laying on top of each other, whereas that's different from a straight line thunderstorm wind event where the tree damage will end up being more fanned out from a central point of where the storm you know, went down to the surface and then fanned out away from that point. And this picture here is from the Livingston-Nesis area in Orangeburg County. There was a mobile home that was located right here. And you can see where the tornado went through and had a direct hit. Unfortunately, the kind of debris from that mobile home is all over here to the right near the road. And this is unfortunately where we had the 2 fatalities and 7 injuries. There were some other mobile homes along this road here, off to the left of this image here, that had significant damage as well, and that's where some of those injuries occurred. And you'll note here also the trees over here on the right-hand side of the image. They're turned back in towards where that center of that damage path was. And it just kind of shows again, you know, where the circulation of the tornado was as it moved through there. So to kind of wrap things up here a little bit, we'll go through, you know, Frank kind of showed this already. This is just looking at the monthly tornado climatology for South Carolina. April is the most favorable month for the tornadoes across the state itself. This would apply also for the state of Georgia as well. It's very similar. But the one I want to point out is, if you look at the diurnal climatology of these tornadoes, if you look at that sort of 5 to 6 a.m. time frame where we had them, this is a relatively minimum in the diurnal climatology here. Most of our tornadoes occur from about 1 p.m. to about 8 p.m. In the afternoon, early evening hours, whereas this event here, they occurred in the early morning hours. During this 60-year, or actually from 1950 to 2019, you know, during that 5 to 7 a.m. hour time frame, there's only 4 significant EF2 tornadoes or greater during that time across the entire state. However, on this particular day, this event, we had 7 significant tornadoes just in our area alone. So it just kind of really shows and highlights how significant and rare event this was for our area. Again, this is the first EF3 tornado or greater in the National Weather Service Columbia area since the April 10th, 2009 event. This was also the most number of tornadoes occurring in a single event since the March 15th, 2008 outbreak, which fortunately or not, I guess I happened to be working radar on that day as well. I seem to have a magnet for these bigger events. But and the early morning timing again was very unusual since our typical climatologically favored time is during the afternoon and evening hours. Looking at some of the values of the environment itself, kind of put those into perspective a little bit. You know, we have observed precipitable water values up around 1.9 inches. And this is a look at the sounding climatology. We don't have a sounding here in Columbia because we don't do upper air, but Charleston's the closest one to us. So this is looking at their climatology down there. But you'll see that value at 1.9 is way above the maximum value on this date of 1.53. So you set a new record. And you can see there, it's really one of the top 3 or 4 values pretty much anywhere for the first part of the year until you get to about mid-May or so. So again, it's a pretty extreme amount of atmospheric moisture available with this event. This here is a look at the Storm Prediction Center Tornado Climatology Database. And I really want you to focus more on the right-hand side there, but I just gave this left-hand image here for reference. This is the point that I chose. There's only a few points scattered around here, but this is kind of the best point location that encompassed most of the tornadoes that we had in our area. So this is looking at a 120 kilometer range within this point here. And so what you'll see over here on the right-hand side, this is a excuse me, box and whisker plot of the various values, the storm or the significant tornado parameter there at the top. You can see that 50% of all the values in the database occur generally in this red boxed area. And then the extreme values, the highest values in the database are represented by this little black point out here. So you can see in this particular case, we had some values up, they got as high as about 11. And so that's almost double what the maximum value was in the climatology. Same for the storm, the significant our supercell composite parameter. We had values up around 36. The maximum value in the database is about 23 or so in this climatology. Again, the shear really high, off the charts. Helicity 800, which is above the maximum value. So just again, to really kind of show and highlight how significant this event was and how extreme these parameters were to be in place that supported this event. And I think it's the last image that I wanted to show. This is basically on the left-hand side is basically the same image I just showed you on the previous slide here for that area in our forecast area. And the right image is the same kind of chart here, but it's centered in central Oklahoma. So just kind of give you an idea of typical the way things look out in the plains, where you have typically more higher, stronger values of these parameters out there. Our numbers here, even so, were on the higher end, even if you were out there, especially the helicity. The effective helicity down there around 800 was actually the maximum, even in this database climatology for central Oklahoma. So I think with that, that's the end of my presentation. So I'll wrap it up, and if there's any time for questions or comments, welcome those.